Here we are at our Chapter 5, Target 4, Problem 7b. We're asked to factor using the difference of two perfect squares. And just looking at our problem, we notice that we have this number 225x to the fourth. Believe it or not, this entire first piece is a perfect square. 225 is a perfect square, x to the fourth is also a perfect square, so the combination of the two being multiplied is going to yield a perfect square. And as a result, we can go ahead then and say that this whole first piece is a squared. It's some a value being squared, because again, this whole piece is all a perfect square. For the second one, we have the number 64 that is also a perfect square. Y to the eighth is a form of the perfect square as well, so the combination of the two is going to give you a total of the perfect square. So for right now, what we'll do is we'll just call him b squared. We also have the difference of these two perfect squares. Now, anytime that you have the difference of two perfect squares like this, you will always factor that out to be a plus b times a minus b. And we saw a lot of these when we were back in Chapter 4. They do make a comeback here, obviously, with polynomials. But when you're trying to break down these polynomials, if you see the difference of two perfect squares like that, it's going to be always a plus b times a minus b. Now, here comes actually the thing that makes this chapter a little more interesting when we're looking at polynomials. We first have to identify what, in fact, is our a and what is our b. Right now, we really don't know what that is. Back in Chapter 4, we could kind of see it a little more clearly because, we didn't have things as higher degrees other than 2. So, just starting this off, we have to identify what is our a and what is our b. So what we'll do is we'll ask ourselves what squared is going to give us this first piece, this a squared. And again, a squared is just this 225x to the fourth power. 225x to the fourth power. Now what we're going to go ahead and do is break this down just piece by piece. So we're first going to just look at this number 225. What number, when you square it, is going to give us that 225? 15 is that number that accomplishes that. Now, obviously, we have to have the x in there because it's, again, part of that perfect square. So we'll use that x value for our base. And right now, if we were just to square him, we'd only have x squared. Unfortunately, we need x to the fourth. Now, if you recall back to our 5.1 notes, we talked about properties of exponents. And we have to ask ourselves what exponent here, when you square it, gives us x to the fourth. Well, that's actually our power to a power property, in which case, if you have a power, an exponent, raised to another exponent, you are going to multiply those two exponents. And as a result, in order to get that 4 here, we would have to have a 2 as that exponent for x. Because again, a power raised to a power, multiplying those exponents, 2 times 2 would give you that x to the fourth. So right here, what we've done is identified this is our a. Again, before we had a squared according to the actual problem, but we were trying to just get what is a, just a. Now we're trying to get b. And the nice thing about finding b is it's actually the exact same process. So we're asking ourselves what squared gives us that 64 y to the 8th. Because again, that second piece is really just our b being squared. So we are asking ourselves what number, when we square him, gives us just this 64, the number 64. Well, we know that 8 would accomplish that. We would also have to figure out what exponent will we need for this other piece, this y to the 8th. Well, we certainly need the base of y. Again, power to a power, we are multiplying those exponents. In order to get that 8, we would have to have an exponent of 4 here. Because 4 times 2 gives us that y to the 8th that we're hoping for. So again, just like before, in the previous one we found our a, this one now is our b. And pretty much all it is here now is just throwing our a and b into the formula. So we have our a, 15, x squared, plus our b value, 8, y to the fourth, times times our a value, 15x squared, minus our b value, 8y to the 4th. And we would, of course, always ask ourselves, can we break these down even more? For this particular factoring problem, unfortunately, we cannot. So this would be as much as we could possibly break this one down. But again, though, that is problem 7b from our chapter 5, target 4.